Okay, this is our Inequalities Day 5 lesson, our second lesson for the week. And today we're solving multi-step inequalities. So we're going to see some familiar setups. We're going to see variables on both sides of the inequality. We'll see addition and subtraction and also multiplication and division. So these are like our two-step equations that we learned earlier this year. The first couple problems on your homework will say match the inequality with its graph. So basically you're solving the inequality and then you're just picking which graph it would match with if you were to graph the answer. So we solve a multi-step inequality the same way that we would solve an equation. So you guys definitely have some background knowledge on this, okay? Because again, this was way back in the fall. We've been solving two-step equations all year. So now it's just an inequality. So the first thing we'll do is we'll add 4 to both sides. And we have 7b is less than or equal to 14. Okay, so we added 4 to both sides. Remember, we always do our addition and subtraction first. And then we need to divide both sides by 7 to solve. And b is less than or equal to 2. So now I come over here to the graph and I say, okay, which graph matches this solution? Well, these bottom two graphs are on a -3. My solution was not -3, so I know it's not those two graphs. It's less than, so I know it's not this one because that's greater than. So it has to be this graph. All right, is what it matches with. Okay, so let's come over here and let's work our second problem. Again, our addition and subtraction always comes first. So the first thing you want to do is subtract 2 from both sides. And you have -6g is greater than or equal to 18. All right, so now, what do you think you do next? Divide by -6. But wait a second, all right? So yesterday we learned what happens when you have to divide by a negative, when there's a negative number connected to your variable. You have to reverse. Now it's not greater than, it's less than or equal to -3. That's going to change which graph you pick, right? So you'll pick the wrong graph if you forget to reverse your inequality. So now that I know it has to be less than or equal to, I know it's going to be this graph, the third graph, that it would match with. So that's the first couple problems on your homework assignment for day 5, is just matching the solution with its graph. So in example 1, we're solving multi-step. And again, guys, the most important concept in this lesson is we always do our addition and subtraction first. Okay, we always have to do that first. So let's look at the first inequality. Hopefully you're kind of thinking ahead of me right now and you know that you need to add 4 to both sides first. 2v is greater than or equal to 12. Divide both sides by 2, and v is greater than or equal to 6. All right, that's about as straightforward as it's going to come in this lesson. So then we just plot our graph. All right, and remember, you're going to have a symbol in your options at the bottom of your screen that will match greater than or equal to. That should have a closed dot with an arrow going to the right. Okay, a closed dot with an arrow going to the right, showing that all solutions are greater than or equal to 6. If I were to plug in a 7 back up here, it would make the inequality true. Okay, so let's look at the middle one. All right, so the middle one, I see some division, but we'll deal with that in a minute. The first thing we want to do is subtract 7 from both sides. And now we want to rewrite our inequality. Okay, now what do? So hopefully you're thinking multiply by negative 6. Multiply by negative 6. And y is less than negative, hold on. What did I have to multiply by? A negative. So now it's not less than. I have to flip my inequality, and they do this a lot. They put these negatives, multiplication and division, they put negatives with a variable a lot. So we really have to get into a good habit of catching that. Because I had to multiply by negative 6, I had to switch my inequality. Okay, so that's going to throw off your graph on your answer. You'll only get half credit if you forget to switch it. All right, so now we have negative 12. 1 less is negative 13. And negative 11. Open dot or close dot. Open. Arrow going right. All right, last but not least, I've got a couple things going on here. All right, the first one is that my variable actually comes after the inequality. So the first thing I want to do is I want to take this and I want to put it before the inequality. So now I have 5 minus v over 3 is less than or equal to. So see how it's closed off? See how the inequality is closed off towards that side? I'm keeping it closed off towards that side. 6. Okay? So now what do you think you're going to do first? Hopefully you're thinking subtract 5. All right, I've got to get rid of the number by itself before I worry about what's connected to the variable. So subtract 5 from both sides. Okay, so now I have negative v over 3 is less than or equal to 1. Okay, so this negative that's floating out in front of the fraction, just as a reminder, you can't have a negative variable. That's going to be a problem. So if there's a negative, you must take it with you to the other side when you multiply. So if you multiply negative 3 times negative 3, then it'll cancel. Then you just have to make sure you multiply this side by negative 3. All right, so those negatives, that's definitely an area that could mess you up a little bit if you miss it. Okay, so really watch out for those negatives. Now I have v, but what's going to happen to my inequality? I had to multiply by a negative. It was connected to my variable. So I have to switch my inequality. Negative 3. So now it's greater than negative 3. And I put that on my graph. See these graphs, guys? These graphs are always going to be a part of your solution. You will be graphing these. All right, close dot and arrow going to the right. All right, so moving on to example 2. Now we have variables on both sides of our inequality. So it's important here, there's more than one way to solve this. My thinking is I do not want to have a negative number connected to my x. Okay, so I'm going to subtract, or I'm going to move the smaller of the two. And that's something that I've taught you guys with equations. I want to look at my x's and I want to say which one is the smaller value of the two. Because 2x is smaller, I'm going to subtract it to the other side. So basically I'm moving my variables to the left side of the inequality. Well, if I'm moving my variables to the left, where do my numbers need to go? My numbers need to go to the right. So now I can add 5 to the right side. You can do that in one step. So now I just combine my terms. 6 minus 2 is 4. X is less than 11 plus 5 is 16. Divide both sides by 4, and x is less than 4. All right, and I graph it. 4, 3, and 5. Open dot or close dot, going left. All right, at any point if you guys need to pause to, catch up or to finish solving, just remember that pause button is always there. All right, so variables on both sides, no problem. I shift them around and then I can solve. But then we have something called special solutions. And if you remember back to chapter 1, I had these special solutions where it might be no solution, my answer, or it might be infinite solution, meaning that there's infinite answers. And that same thing is going to happen with inequalities. And it's usually going to be hidden in the distributive property. So I can't just look at this inequality and say, oh, that's no solution, or that's infinite solution. I need to first do the distributive property. 8b minus 3, there's nothing to do on the left, is greater than what's 4 times 2b? 8b, and what's 4 times 3? 12. So my first indicator that I have a special solution is that I see that my variables are the exact same value. So remember in the last example, I'm trying to, okay, which one's smaller, right? Well, if they're both 8b, neither one is smaller. So when you try to move it to the other side, what happens? Yeah, it cancels here, but it also cancels here. So when the variables cancel on both sides, what is left? -3 is greater than 12. And you ask yourself, is that true? It's not true. Because it's not true, you will say no solution. There's no solution. So how do you know it's a special answer? Your variables, when you try to move them to the same side, they're going to actually cancel out completely. So you know it's a special answer. So let's look at this next one. 10w, I did that by distributing. And what's 2 times -1? It's -2. Is less than or equal to 7 plus 10w. Okay? All right, so again, my alert's going off because I've got these 10w's that are the same. So what's going to happen? Well, when I try to subtract them to the other side, they both cancel. So now bring down what's left. -2 is less than or equal to 7. Is that true? Is -2 less than or equal to 7? Yes, -2 is definitely less than 7. So because that's true, you're going to have infinitely many solutions. Any value you plug in for w, any value you plug in for w will make this inequality true. You have infinitely many solutions. Okay, and yeah, that's what I thought. That was the last question for day 5. So, just to recap, we were matching up the graph with a solution. We also solved special solutions in example 3, variables on both sides, and then just regular multi-step. And that's everything for day 5.